Hello, everybody. Welcome to Knowledge India. Let's see how many of us are here. If you are able to hear me, I would request you to kindly reply. Hello, Sudhakar. Hello, everybody. Welcome to Knowledge India. Hey, hi, Lucky. Hello, Anita. Let's see who else is there. So it's 9:31. We'll give like 2-3 minutes, and then we'll get started. In the meanwhile, people who are there on the who have already joined, I would request you to uh, Hey guys, I'm sorry. I think there was a glitch in between. If you are able to hear me now, please respond. Okay, in between there was a drop, I suppose. I'm sorry about that. Are you able to hear me now? Please reply once. Those who are there on the session, those who have joined in the session, I request you to please type in the chat window once so that we can get started. Okay. So Anita is saying yes. Lucky also says yes. Okay. So that means okay, we are able to hear good. Uh, all right. So we will get started now, guys, and let me see. Anybody who has joined and if you have joined just now, can you please type in the chat window so that we know that you are there? We are about to get started. Okay, all right. Thanks for confirmation, guys. Uh, in that case, we will get started now. So Manu also has replied. Okay, great. Fine. So let us get started. Thanks for being here, all of you. So in this particular session, as promised, we are going to talk about decoupling. Many of you have earlier requested as well that there needs to be a tutorial on SQS, SNS, and all of that stuff. So I thought, why not we use a part of this live session to talk about those things, and we should be able to we should be able to take few examples and discuss those things as well. So in any architecture, it is very important to decouple different layers, because when you decouple different layers of your architecture, the scalability becomes easier, right? And also when any component in one particular layer fails, it becomes a lot easier for for other components and other layers to handle such situation. Now, in order to understand this thing, what you can see here is, on the screen you can see we have two architectures in front of you. On the left hand side, we have a web tier and app tier. So we have different instances running there. Let's say in this case we have three instances in the web tier and app tier. Now, because requests can go from any instance to any other instance in the other layer, it happens that all of the instances in the web tier, they are sending requests to all different instances in the app tier. In this case, what would happen if a particular app server goes down? Let's say the first one, which is there on the leftmost, that app server goes down. In order to handle it, you will have to, meaning, if let's say if this particular instance goes down, I'm saying this particular instance goes down, then all the requests which are coming to this particular instance, all those requests would start failing, and you would not want that to happen to your application, right? So why is it happening? Because it is very tightly coupled, right? The two layers are very tightly coupled. Instead of that, on the right hand side, if you see, if we introduce a load balancer in between the two layers, as the instances in the web tier, right, they would not be sending the traffic directly to these instances. Rather, they would just send the traffic to the load balancer, post which it is the responsibility of the load balancer to check how many healthy instances are there in the app tier, and send traffic to any of those instances. Now, in this particular scenario, which you see on the right hand side, let's say this particular instance goes down, this would fail because load balancer would be able to detect that, and load balancer would not send the next request to that particular instance, right? So that is how with the introduction of a load balancer, which is or ELB, between your two layers, you are ensuring that you are ensuring that things are loosely coupled, and when a particular a particular instance goes down, things continue to work. Okay, a quick check, guys. All of you are able to hear me? uh, Probably the connection is not very great, I'm sorry. But if you can just at regular intervals give me a ping on the chat or a smiley, it would help me. So if you are able to hear, can you please update me, and then we move forward. All right, thank you, Tarun. Thanks for replying. Thanks, Avinash. Guys, I would request you to to try and just just uh, chat in the window at regular intervals, right? So that would just help. Thank you. Now let's take another scenario. Uh, let's say on the left hand side, or in this particular architecture. So first scenario, we talked about a particular instance going down. Now let's say in this particular architecture, or in the web tier and at the app tier, you are implementing auto scaling, which means on based on the incoming traffic, based on the number of hits or number of visitors on your website, the number of instances in your web tier and your app tier would increase or decrease, right? So that's why you are implementing auto scaling. So when you are implementing auto scaling, it can happen that instead of these three servers, one more server comes up. Let's say one more server would be there, four servers. Now you will have to take care of you'll have to take care at the application level that when a new server comes up, it should know how many instances are there in the other layer, so that it should know that I should be sending traffic to these three instances. Later on, let's say if here also it becomes four instances, then again you need to update everywhere that now you can send or you can distribute traffic to four instances. That would be very cumbersome, right? Continuously updating it or telling each and every instance. So instead of that, in this case as well, if you have a load balancer between these two layers, how it helps us, doesn't matter on this layer you have three instances or you have four or five instances. In the same way, in the other layer you got three instances or four or five instances at any point of time. It doesn't matter, right? It is always the work of your load balancer to distribute the traffic. So what I'm trying to say in summary is, let's say here you have got three instances, it becomes five. Even in that case, all of the instances will continue to send their traffic only to one load balancer. And it is the responsibility of this load balancer to then distribute the traffic to either three instances or to five instances. Let's say if auto scaling went ahead and increased the number of instances in this layer, load balancer would be aware of that, and load balancer would distribute the traffic accordingly. So that's the benefit of introducing a load balancer in between your two layers, for example your web tier and app tier. And in this scenario, if you see, sometimes earlier we have talked about public or private load balancer, or we can also call it external or internal load balancer. Whatever you see on the screen, this thing is actually a private or internal load balancer, because it is not going to get any traffic from outside world. It is going to get traffic from certain instances which are part of your VPC itself, right? Though in front of web server, if you put a load balancer here, right, and the above the web server layer, if you put a load balancer, that would be public facing load balancer. And why we are calling it public facing? Because it is going to accept, it is going to accept or receive traffic from everywhere in the world. Okay, so I hope we understand that why we should introduce load balancer. If you understood, please go ahead and acknowledge it. Okay, thank you, Devang. Thank you, Lucky. All right. Thanks, Avinash. Thanks, Bala. Okay. All right. So that was one thing. Now, last point to add here, guys. In a typical three-tier architecture where you will have web tier, app tier, and below app tier, you will have your database layer or database DB tier, right? You don't need to put an ELB between your app tier database, because if you see at your DB layer, at least in case of relational databases, you don't have to do that, because in case of relational databases, it is going to be one instance or one endpoint to which you will be sending the traffic. So typically, you will not be putting a load balancer between your app tier DB layer if it is relational database. So that is just a quick info to add there. Moving on, next thing we will talk about SQS. SQS is simple queue service, and as the name says, it is really simple. It is a completely managed service. So as a user, you do not have to worry about running any server. You do not have to worry about space getting over. You do not have to worry that suddenly if you are going to use, or if you are going to write a lot of messages to the queue, you have to increase the infrastructure and all of that. You don't have to do that. Rather, it is a completely managed service, and Amazon takes care of it for you. Okay, Avinash, there is a lag. I mean, there is an introduced lag in the transmission in order to improve the quality. So actually, whenever I say or whatever I'm speaking, you would be seeing it on your screen after a few seconds. So if it is that, it is a known stuff. Okay. All right. Let us understand why do we need queues? Why are they important? Now, queues as such help you in order to streamline things. First, let me take a very simple example and talk to you that how does it help you. Uh, Before going technically, let us just think of a simple example. All of us go to our cafeteria during lunch in order to have our meals or have our food. Now, doesn't matter, in our organization there might be 200, 500 people who are going to a counter and getting the food, but still 5 or 6 members which are working at that particular counter, they are able to serve the food to all of us, right? And it is possible because we stand in a queue and we basically get our food. Now, if all of us try to go and take the food at one time, it is not going to work. So we introduce a queue and it becomes simpler, right? Similar type of work happens in case of computer world as well. So queues are nothing but, you can think of them, think of queues as simple pipes, right? They are like a pipe, and in this pipe, from one side, continuously writing messages, right? And on the other end of the pipe, another process is continuously reading it, right? And as it reads a message, it understands, it reads that what is the content of the message, it will go ahead and then process that message, right? And once it is able to process the message, it will go ahead and delete it from that particular queue or pipe, right? So how, I mean, what is the benefit? The benefit is that, first of all, unless until a message is processed, there is no chance that it will get deleted. So for example, there's a message, let's call it message 101 in our queue, and our process 101 read that particular message, and while it was trying to process that message, somehow that particular process crashed, or that particular machine crashed, right? So because it crashed, that means this message 101 has to be processed once again. And queue ensures that unless until the successful processing of the message happens, and then you go ahead and delete that particular message, that message will remain there in the queue. It will not go anywhere, right? And maybe another process 102 can go ahead and pick the same message and then process it, because it did not get processed earlier, right? So quickly, in order to understand SQS, what all we need to know in SQS, what you do is, first of all, you go ahead and create a queue. You give it a name, you basically create a queue, you give few parameters, that how much would be the size of your messages, etc. For how much time do you want to retain the messages in the queue. Maximum retention period is there for 14 days, 14 days. And every message can be of maximum size of 256 KB, right? Now, so these things maximum you can define, I mean, while creating the queue you can define these things, but these are the maximum values. Now on a particular queue, on both the sides, while reading and while writing, multiple processes can continue to can continue to read and write at the same time. And the way they read or write to the queue is via using AWS APIs. There are simple AWS APIs to basically write a message to a queue and to read a message from the queue. Okay, so it's very simple. And good part is, you do not have to pay anything in the start, right? I mean, it's nothing like you have to provision any infrastructure. Some of you might have used, or surely would have used, uh, uh, things like RabbitMQ, right? So you go ahead and you set up a server and you install RabbitMQ. Many times it goes down, you have to plan for the capacity based on the number of messages you are putting. Here you don't have to do any of such stuff. All you do is just go ahead, create a queue, and it is fully managed. You just set up the rights using IAM to whichever user or role you give the permissions. Only that particular guy would be able to read and write from the queue, and it's very simple. Okay, and amount of messages which you read and write, based on that your billing happens. Okay, so it's simple. So now let's talk. I'll take a pause here to get acknowledgement from all of you, and if you are finding it good, maybe a smiley as well. Anybody who has joined us now, in between, or recently, you may also say a hi so that we know you. Meanwhile, I would also request you guys that please go ahead and take this link and just tweet it or put it on your LinkedIn that you are attending this particular session. Just take this URL and go ahead and share it on your Facebook or LinkedIn or Twitter, and say that you are attending this session on AWS. If you can do that, it would be great, please. We'll wait for a few seconds and then we'll get started. Okay, thank you. Thanks, Lucky. Thanks, Avinash. Hello, hey, hi, Manuel. Akilan has joined. I think you have joined us for the first time. Satish, ready? Hi, Satish. Okay. So I'll give a min. I'll give 30 seconds, and after that we'll resume. In the meanwhile, if you can go ahead and just share this URL on your networks, it would be great. That would be helpful, please. Yeah, Sashi, I'm coming to that just in a while. All right, guys. So as you can see on the left hand side, uh, there is a architecture pattern which you can see, which which represents asynchronous processing. So let's say you take any billing system, or you take any uh, somewhere from one format of the file, other format is getting generated, or maybe based on a particular request, a bill is getting generated. There are a lot of batch processing which happens where data gets processed through different through different business processes basically, and the result of one business process is consumed by the second business process, right? I'll try to tell you one of the example which you might have seen or noticed as well, and then I'll come to this. So I'm sure all of you would have done shopping on uh, uh, okay, Emmanuel, I meant the URL of the of the current session. If you just and share, it would help, of the current session. Yep. So I'm sure all of you would have done shopping on Amazon.com or Amazon.in, or depending on the geography where you are. Now, many of the times it happens that when you go ahead and you do the payment, basically the request goes to the bank, you have done successful payment, there is no failure, nothing. The request comes back, and you still see a red color text which says payment happened, but the order is still not placed, or it is not yet confirmed. And then within a period of probably 2 minutes or 5 minutes, you get second email which says your order is successfully placed now and we are good, right? Something like that. So what happens in that duration? It is not like it has to go and check with the vendor or the seller that you have the items available or not. Generally, how many items are available that you get to see before itself, that only one item left or two items left or things like that. So why is it taking that time? Though a success message has come from the bank, why is it that first it says that it is still not completed, and after few minutes you see a success message? What is happening in that time? So actually in that place also queue implementation is there. Now try to think it in this manner. When a when you are buying something, basically when a success message comes from bank, that is the trigger point, or that is the event when lot of things get triggered in the backend system. Probably an email has to go to the seller, an email has to go to you. At the back end, probably in a lot of different tables, things need to get inserted. A complete workflow gets started once you do the payment. Gets completed only after you have, the item is delivered to you, or in case you return, then that workflow goes even further. So need to happen at the back end. Now there are two ways in which a company like Amazon could have handled it. One is that doesn't matter how much, or doesn't matter how many people are buying on their website, they continue to increase their infrastructure more and more, so that as soon as request comes from the comes back from the bank, all the necessary actions at the back end can happen immediately. But looking at the scale at which Amazon operates, that's really not possible, because millions of people buy every day from Amazon, right? So what they do is, instead of that, they introduce a queue in between, and as soon as your message, success message comes from the bank, it gets inserted into queue. And at the other end of the queue, a process continuously keeps reading these messages, and as it reads the message, it will go ahead and trigger n number of things at the back end. That's why once that is processed, you get another email saying that it's all done, it is good. So I hope that makes sense. So in a nutshell, if I try to tell you, it is perfectly possible that in a system, whenever an event happens, you go ahead and do 10 other items as a result of that. But if you are operating at a very huge scale, at a very large scale, it might be a bit difficult for you, because you will have to put lot of infrastructure in order to handle all such things at the same time. So instead of that, you can introduce a queue in between, and as messages keep coming, just keep putting it into the queue, and on the other side of the queue, you can have your processes which are reading from the queue, and they are just processing it one by one. So you have basically introduced a kind of serialization, a queuing mechanism you have introduced, so that on the other end, even with lesser infrastructure, comparatively lesser infrastructure, you are still able to process each and every message with a small amount of delay, but then you save a lot on the infrastructure. Also, at the same time, if let's say the process which was doing, or which was which was processing your messages, if it goes down, the message would not get erased from your queue. As I said, the retention period is there for 14 days. As soon as your process comes up, it can again pick the next message and it can process it, right? So those are the benefits of dealing with queue. On the left hand side, if you see on the screen, that is what I've tried to explain. Let's say there are three different processes. So here there are few instances where processes are running. Here there is another set of instances where some processes are running, and here is the third process which is running. So when first process has done its processing, it would just put a message into, right, into an SQS queue, and continuously the second process will be polling this particular queue in order to get the next message. And as soon as it gets next message, it will try to process that. Once it has processed, it will put the result message in next queue, and from there, and as it puts the result message into the next queue, it will also delete that message from the first queue, so that it is no more read, right? Because this process was able to successfully complete or successfully process that message, and hence it will delete that message from this queue, and it will put the result as a message into next queue. And again, the same pattern, right? Queuing. Then your process 3 will read next thing from this particular queue. Let us see a few things on the right hand side. Anil Kumar, this is the first session I'm attending. I'm Windows administrator, completely new to AWS. Guide me the best site or tutorial for AWS from beginners. So Anil, I would request that on our channel, there is a playlist which is there for AWS SysOps. I would suggest just go ahead and follow that playlist. That will be very suitable for you. Just on the channel, go ahead and look at the AWS SysOps administrator playlist. Virag Jain, how much messages can be queued at one particular period of time? That's literally unlimited. Only the size of every message is limited to 256 KB, but how many messages you can put? As much as you want. There's no limit on that, Virag. That's the beauty. Devang is asking, how long can the gap be between two or more consecutive processes in a queue? Let us understand, the process is not happening in the queue. What queue is doing is that it is getting the message, and then on the other end, some process which is running on an EC2 instance is reading the message from the queue. Now if we ask that whether there is any gap required between two processes accessing a queue, no, there's no gap required. Two or more processes can continuously poll a queue and get the next message. In the same way, two or more processes can continuously keep writing to a queue. Please acknowledge if you people are able to understand and follow it till now. Okay, Rangesh, I was thinking that why didn't you join? Okay, now being enabled by default, SQS is a separate service, and if you want to use the service, you need to go ahead and create a queue, and you need to use it from your code. There are simple APIs available with which you can read and write to an SQS queue actually. Sashi is asking, how do we integrate EC2 with SQS? I think that is what I answered just now. So let's say you are writing an application, right? Maybe in Java or .NET, right? Anything. So using AWS APIs, there are APIs available to read and write from an SQS queue. So with your application, you'll have to write that, Sashi. First create a queue, and after that within your using your application, whichever language you are writing your application, use the AWS SDK and read and write to the queue. Virag is asking, do I need to pay any extra charges to AWS, say for a scenario of OTP where request is unlimited? I don't know. I think you are mixing two things with one. Are you talking about one-time password with SQS? How come one-time password is coming? I'm not sure. Virag, I would request you to elaborate it more. Rangesh is asking why there is emphasis on queuing system from Amazon, whereas on a day-to-day basis, we don't bother much about queuing in our on-premises infrastructure. Okay, that's a good question. So Rangesh, it is not a single rule that we should use queuing pattern everywhere. Of course, it is not acceptable also everywhere, but there are certain scenarios where queuing is good. There are certain scenarios where queuing is not good. Let me take scenario examples for both of these. When you go ahead and deposit some money in your bank, you would want to you would want to get it reflected immediately. You would not want even a delay of probably 2 minutes before it shows up in your account. The moment you submit it in the counter, you want it to be you want it to be displayed in your account, right? So there queuing is not a good thing, no, right? But the sometime back, the other example which I was saying, which I took, where I said that a very big organization, a very big e-commerce company like Amazon, where millions of people are buying every day, once they do the payment and successful message comes from the bank, it is okay to go ahead and queue it for probably for actually few minutes, and after that process that message, because anyway from bank side it has come, so all the third party work is done. After this it is all Amazon's internal processing, so it can queue that message for some time, and maybe in next few minutes it will go ahead and pick that message and process it. If it doesn't do that type of queuing, or if it doesn't use the queuing architecture, they will have to put lots and lots of infrastructure in order to process each and every request in the real time. So it is always the choice, or basically as part of architect, you need to choose, or you need to decide that in which part of your application you need the response to be immediately available, and in which place, and in which places it could be asynchronous, and hence you can make use of queuing. All right. Some of you have acknowledged. Thank you. Akilan, Devang, Lucky, Emmanuel, Satish. Thanks a lot to all of you. So I'll move to the next topic, which is SNS, Simple Notification Service. Now, Simple Notification Service, as the name says, this is again a 100% managed service, so you do not have to do anything. Let us understand why this particular thing is used. This service is used to basically notify between one process and another process. Many of the people who have read SNS, they think that this should be used to send emails or to send messages basically. No, this is not the service to send emails, right? This is not for that purpose. Okay, rather SNS is meant in order to notify another process. Let's take an example. If you want on an S3 bucket, and I request you I request all of you to go ahead and check that later on. I think I've shown it in my demo earlier in S3 as well. So if you go ahead and check an S3 bucket, on the right hand side you have an option of event notifications. So you can go ahead and choose an event. Let's say if a new object is created in your bucket, you want to raise an event, and that event will go ahead and it can either it can notify an SNS topic, or it can go ahead and invoke a Lambda function, or it can put a message into an SQS queue. It can do any of these, right? So 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 we need to understand that why SNS is getting used. As soon as somebody came, or because of some reason a file got uploaded into your S3 bucket, immediately an a notification or an event notification went to your SNS topic, and now to this SNS topic n number of people can actually subscribe to. So the way you receive, or the way you get to know, or the way you get to know from an SNS topic is that you have to go and subscribe to it. Okay, and there are different ways, different protocols through which you can subscribe. So once you create an SNS topic, you can go ahead and subscribe to it via email, either via HTTPS URL. You can also just neglect this, it is not USA only anymore, it comes to all the countries now. You can also get SMS on your phone. A message can go inside an SQS queue as well. Okay, from an SNS topic, a message can be pushed, or basically in your mobile, a push message can also come from the top. In addition to this, you can also invoke a Lambda function where any custom code which you have written, that gets executed. Okay, so these are the different ways. So let's take an example, right? You have an S3 bucket. What you want is, whenever an object gets uploaded, you want an email, right? So what you do, go to your S3 bucket. On the right hand side in the event notification, you need to go ahead and select the event. The event is that when an object is created, and then you choose that what action you want to do. You want to send a notification to one particular SNS topic. So either you could have created an SNS topic already, or you can create at that time and choose that SNS topic. Let's say somebody uploads a file called logo.jpg. Immediately a notification will go to your SNS topic. Now anybody who has subscribed to that SNS topic will further get a notification, and it might be possible that 3 people have subscribed to that SNS topic via email. 4 others have subscribed via SMS. Somebody else has subscribed via somewhere else, some other way, right? And it might be also be possible that a Lambda function also is subscribed from that SNS topic. And what happens? A Lambda function is invoked, and that Lambda function will go ahead, pick that image, and it will create a thumbnail out of it, right? It can do all of that. So that's your SNS, guys, which actually brings us to to compare between the two. Many times people get confused. So before I talk about this, let me see some of the things on the right hand side. Emmanuel has asked for how long the queue keeps the messages. Bala has replied, thanks Bala. Yes, the maximum time is 14 days, though you can set it lesser as well, but the maximum time is 14 days, Emmanuel. Rangesh, crystal clear, number 1. So it's not like an EBS or S3 service. We have to invoke SQS either by SDK or API. Yes, right, that's right. And this service is not wise to use for all the jobs. Yes, that's correct, Rangesh. But jobs whichever demands proper queuing, like banking, inventory processing, it's good to use SQS. As I said, wherever asynchronous processing is okay, where it is fine to have a smaller amount of delay in the process, it's okay. Any batch processing, this is good. Bill processing, batch processing, monthly, a lot of processing happens. A lot of scientific organizations, they process lots of data. And it might happen that while the processing is going on, many of the times 1 or 2 instances or some processes may fail, right? So in such cases, it is a wise decision to go ahead and use queuing, so that even if a process fails, when it comes up, the message is not lost. It can again pick up the message and it can start processing it. So I think that should clarify to all of you. So guys, if you are able to understand, please give me a thumbs up, or smiley or whatever. If you are angry, you can show me an angry smiley as well. That's fine. Uh, all right. So with that, we come to this last slide, and after that, we'll try to do some Q&A, and we'll try to talk about few things. So what we are seeing here on the screen is a comparison between SQS and SNS. So guys, we need to understand in case of SQS, the process which wants next message, it has to continuously poll a queue, right? POLL, poll a queue. So as I had shown you some time back, this particular thing, if you see, if the process running on this EC2, when it wants to read the next message, it has to poll this particular and get the next message, right? Whereas in case of SNS, it is a push mechanism. Somebody who has subscribed to a topic, he need not go and poll, right? He need not, if I have subscribed to a topic, that's it. Once I've subscribed, once I have verified my email, my work is done. Whenever some event is happening, I'll get the email automatically because it is a push from AWS side. Okay. In the same way, what about message persistence? In case of SQS, there is message persistence. As I told you, maximum it can be for 14 days. In case of SNS, it is not. As we saw, it is a push mechanism. Once a message has come to SNS topic, it will just push to all the subscribers who are subscribed to it, and it will not it's not that it will keep it for n number of days or things like that it will not do. So I'll take a pause here and would like to hear acknowledgement from all of you, and after that we move forward. Thanks, Bala. Others, are you able to understand what we are talking? Thanks, Virag. Thank you, Akilan. Hey, hi, Ankaj. Did you join late? This is the first message I think I'm seeing from you. Thank you. Okay, Devang, Mano, thanks. All right, that's great. Thanks, guys, for acknowledging. Some of you have not, but I'm just hoping that you are seeing the screen as well and not just listening and browsing somewhere else. Anyway, so here are a few questions which I have received from Rangesh, actually. So let us go ahead, and these questions are related to the exercise which is given on the blog, which is actually looks like a small one, but if you go ahead and do that complete exercise, you might get a lot of doubts. Those of you who have not done, I would highly recommend that please try and do it, guys. That covers a lot of things. So here are a few doubts. I'll try to go through those and I'll try to explain them, and any other doubts you'll have, I'll try to take that as well. Abraham, I think I'm seeing you for the first time. Welcome to Knowledge India. So Rangesh is asking one final question with SQS. So let's assume I'm invoking the SQS function on my EC2 instance, but how does the SQS works internally? Does it liaise with the RDS or applications? No. You can think of SQS as a black box, actually, Rangesh, because it is a completely managed service. You can think of it just as a queue or a pipe, and AWS is giving you one API to write to that and one API to read from that. How they implement it at the back backend that they do not expose to you. But yes, one thing we all can know and understand, that all the data which with whatever we write on an SQS queue, that is automatically replicated to multiple availability zones within that region. So SQS and SNS are also region level service. So let's say you go ahead and you create an SQS queue in North Virginia region. Automatically, you will not be choosing any availability zone while creating this particular queue. Automatically, all the data which you write to this queue gets replicated to multiple availability zones, and this makes sure that at any point of time the data would not get lost. Okay, Rangesh, the delay has been introduced purposefully in order to keep the quality better. Okay, all right. So we will go to the questions on the left hand side. Guys, let's see. The load balancer is only for external traffic to come inside, right? I know it is. My below questions are going to be based on this. Will the internal load balancer sit in private subnet? Yes. So as I was talking in this particular slide, if you see, we have a load balancer which is private or internal. When you are creating a private or internal load balancer, you are going to keep it in the private subnets. It is not going to receive any traffic from the outside world. Receive traffic from the instances which are part of your VPC only. So this is how an internal load balancer works. But in the exercise, what I have talked about a load balancer which will be above web servers. That one will be public facing load balancer, and that should needs to be put in the public subnets, guys. Okay, next is it a good practice to have an ELB between the web server and the DB? If the DB is read replica and AZ, I suppose it is multi-AZ, or is RDS DynamoDB intelligent to have its own load balancing mechanism? And between, I tried adding DB, which I installed it through RDS, and not able to see the instance, though I'm able to see the private subnets. Okay, there are multiple things involved here. First point, I think I talked at the start. Between your, I mean, just above your DB server, you need not have your ELB, because the way your RDS instance or relational databases work, it is going to be one endpoint. There are not multiple endpoints below which needs to be hit, right? Even in case of multi-AZ RDS, you get only one endpoint. It is the work of RDS internally to ensure that request always goes to primary, and secondary is acting as a slave, right? It is its internal work, so you don't have to worry about it. Okay, so you will be using an ELB only between your web tier and app tier, and you will not use an ELB above your DB. You may think of using an ELB above your DB only in certain cases where you are using a NoSQL databases which is spread on multiple instances and you are managing those EC2 instances. In such cases, you may think of using them. All right, in case of RDS, the way to check is via telnet. Never try to ping RDS instances. If the load balancer takes only HTTP traffic on port 80 through listener configuration and not any other traffic, which means whatever incoming traffic the load balancer allows, those are the protocols I can specify in the security groups too, right? Correct. Yes, Rangesh, because the load balancer's incoming traffic is directly proportional to the security group traffic that I can allow to the instance. A few things, I'm not sure if I'm getting this question correctly, but let me explain this to you. You should have a different security group for your public load balancer, right? Your external facing load balancer. Then you should have a different security group for your web servers. You should have a different security group for your internal load balancer. You should have a different security group for your app tier as well, right? Now, once you have all these different security groups, it becomes very easy. The security group which is there for your public facing load balancer, there you will allow port 80 from everywhere, right? Whereas your web servers will be accepting traffic on port 80 only from the public ELB's security group. If any of you have a doubt that how to put a security group ID into the security group rules, please go ahead and watch the tutorial which is about the security group on the channel and understand it properly. But that is how it would be. Okay, next question is why we put a NAT gateway, obviously for the instances in the private subnet to interact with the internet, for patches networks. So the outgoing traffic goes through the NAT gateway. Okay, but it can't be one way, right? Where does the return traffic come through to the respective instance? If your answer is through the same NAT gateway, then do they bypass the ELB? Okay, the way it works, guys, is you have to, as I have told multiple times, there is a tutorial. I request all of you to go ahead and see the difference between NAT versus ELB. There I've explained this thing very clearly. When a private instance initiates traffic going to the internet, it goes via NAT gateway, right? The initiation is happening from the private instance and it goes to the internet. The reply will come back via NAT gateway itself. Okay, it went via NAT gateway and the reply also will come via NAT gateway. Whereas in case of ELB, what is happening? From the outside world, traffic is initiated and it is coming via ELB to your private instances, and the reply is going back from your private instance via ELB. Please watch the tutorial which is explaining this difference between NAT and ELB. It will be all clear, guys. I highly recommend you watching that tutorial. RDS, in case of HA, you had mentioned that we have to take care of multi-geo replication by ourselves. In one region fails, how do we do that? Okay, so it is recommended, guys, that if you want 5 nines of availability, then Amazon says that you should run your infrastructure in 2 different regions. Now if you have your database, be it RDS or any other database, in 2 different regions, you can go ahead and use any data migration tool which you like. You can use any third-party tool, or you can use even Amazon's DMS, data migration service, to replicate the data between 2 regions. Of course, there will be some lag depending on how much latency is there between your 2 regions and at how much frequency you are syncing the data. So those things will be there involved. What happens while placing the ELB in a subnet if I choose AZs separately, meaning I create 2 load balancers and I attach the AZs separately? See, it is not right thing to basically go and create n number of load balancers. Rather, in one layer there should be one load balancer, but while creating that load balancer, you should choose multiple subnets which are there in different AZs, so that this load balancer is internally spread across all those availability zones. That's the right practice to do. Do we have the option to use .pem file to log into RDS and DynamoDB? No, that is not possible. RDS and DynamoDB, they are managed services, and hence you do not get option to log into its instances at all. Coming to the right hand side, Sandeep Singh, I want to know more difference between SQS and SNS service. Could you please explain more SQS service? Sandeep, I don't know at what time you joined, but I think we talked a lot about SQS. In case you missed the part in the start, you can watch the recording. It would be available on the same URL, but we talked quite a lot about SQS already. Rangesh, so basically, even if I have to SSH into my instance, which will pass through the LB, so I should in the listener config. No. Load balancer is not meant for that. Understand, guys, load balancer continuously distributes the traffic to your instances, right? So if you want to do SSH to your web server or to your app server, the way you do is, that's why you create a jump box or bastion host in your public subnet. You first log into your bastion host or jump box, and then from there you do a SSH or RDP to your web server or app servers. That's the right way to do. Load balancer you should be using for receiving all this in website type of traffic. It is meant for that purpose, because it gets distributed. The first request might go to instance 1, the second one might go to instance 3, right? You don't have control on that. All right, I'll take a pause there. I hope you people are able to listen and understand. If you did, can you please acknowledge and let me know? To go ahead and share this URL with everyone. If you have any other doubt, I can take few questions quickly, and after that it is 10:30. We'll have to try and close this. This video is going to be available on the same URL, so you can go ahead and share it with anybody whom you like. If you got benefited, you can spread word to them as well. So I'll wait for a few seconds for your acknowledgement and for any quick questions you might have. Pankaj, though it is possible that you can just choose TCP and port 22, you can enable that. You can basically just put TCP and try to put any port, but it does not make sense, right? So it is not just about whether we can do it or not, but it is not right to do it. Because when we want to log into a particular machine, we would want to log into that machine only and not to some other machine. It might happen that we try to target and it will go to something else. So that's why. Virag, I request you to please look at the channel. There are 50 plus, I mean, not 50 plus, there are nearly 50 videos on AWS. And if you want to just to start very systematically, as I would request that there's a playlist which is there for AWS SysOps. Look at that playlist. You have videos on different topics and you can go ahead and get started. Thank you, Emmanuel. Thanks for your words. Others, have you been able to understand? Thanks, Abraham. You still this recording of this video is gonna be available in few minutes on the channel on the same URL, so you can go ahead and watch the complete tutorial. Those of you who, in case, missed it. Uh, I'll try to do that, but then there are many things. I'll see how much I can do. I'll probably try to maybe show a quick demo, but I would request you guys just please go ahead and try to create a queue, write a message to it, right? I mean, it is possible to go ahead and write an application. Also from the AWS Management Console itself, you can just go ahead, create a queue and write a message from there itself, and then you can poll that queue in order to get that message, right? You can do that. Okay, Bala has asked a good question. What is the rate at which we can write message to SQS? As such, there is no limitation, Bala. We can write a lot. There's no defined rate as such, but it might not be useful or it might not be suitable for real time. It might not be suitable for the real time data ingestion. When I say real time, I'm talking about very high data rates, things like where we are accepting terabytes of data per hour, right? For example, if we are receiving data from lot of sensors, or we are continuously ingesting tweets which are like very heavy, we are every second we are getting a lot of data. In such cases, there's a different service called Amazon Kinesis which can be used in order to ingest real time data. But wherever you need a queue scenario, this is good enough, and there is no as such limitation on SQS. Okay, thank you. Thanks, everyone. Thanks for your time. So I would request and look forward that you will go ahead, all of you will go ahead and please share this video, share this URL on your LinkedIn, Facebook, Twitter, whichever you like. Go ahead and share this, spread the word. And I hope to do more sessions for you, but I'm also hoping that it reaches to more number of people, and the responsibility is on you. So if you friends, it will be of great help. Thank you once again, and I hope to see all of you again very soon. With that, I'll end today's session, and this is going to be available very soon to you. please remain linked. Subscribe to the channel, subscribe to our blog. The links are available on our channel, which is youtube.com/knowledgeindia, and you can go ahead and look at it, subscribe to the blog, subscribe to the channel, and you will remain alerted with whatever is coming up new. Abraham is asking, do you have something for us next, and when that would be? Abraham, as I said, look at our blog, which is the link for the blog is there on our YouTube channel. Just for the benefit of everybody, I can put it here. So please go ahead and open this blog and subscribe to this. Also, on the right hand side, you will have my updated calendar. So whenever I'm creating a new session or whenever there's a live session upcoming, if you add that calendar to yourself, to your Google Calendar, you will be updated. Please go ahead and do that. Question on S3, Satish is asking, if I enable cross-region replication, what are you writing? If I enable cross-region replication, when I create a rule from a bucket from one region to B bucket in another region, and I need to enable versioning on both the side. Yes, you need to enable versioning. Without enabling the versioning, you cannot do cross-region replication, Satish. Ankaj, as far as I remember, in addition to HTTP and HTTPS protocol, a TCP is also allowed. So you can go ahead and choose TCP, and then you can write any port you want. But doing SSH would not be the right thing to do there. Okay, thanks Rangesh for kind words. Thank you. This is good. I like that. Thanks, Bala. Yeah, okay. So I found that some of you have spent time and you are doing the assignments which I have given. So two announcements here. In the next week, I am gonna put many such assignments. This time I'll try to keep it comparatively smaller so that you can finish one assignment quickly. So please subscribe to the blog so that when I write that assignment, you are alerted about it. Also, one of my plan is to write, to go ahead and conduct a small quizzes on the Twitter. So if you follow my Twitter handle, which is there on the blog, if you follow there, I will be posting small questions which all of you can answer, and that way we can test that how things are going. So I request you to please do that, guys, and I'll write to give those assignments. Discipline, that's fine, but when I upload in B, also it's replicating in A. Can I do one-way replication? Okay, now Satish, normally when you do cross-region replication, it is only one way. I don't know how you have done the setup. I'm not sure about it, but normally when you do, it is only one-way replication. It is not both the ways. I think there is some mess up there. Please try it with two completely new buckets and check it. Okay. All right, guys, with that, I will say bye-bye to you, and I hope to see all of you again. And if I may request you, please spread the word with your friends and try to bring one of your friends surely next time with you to the live session. We'll meet again on the next weekend. I'll update the calendar, and please look at the blog to know about it. And please bring one of your friends for sure in the next session. Thank you. Bye-bye. Have a great day. And those who are in India, have a great night.